In this next section, we're actually going to get hands-on here. At least we're going to look at a running instance of VNF Asterisk itself. So kind of organized in this way that we've been looking at here previously, we are going to actually put our hands on it. So just as a quick recap here, we went over what is NFV, what does the block diagram look like. We're going to go through a demo, and then this afternoon we're actually going to deploy the things that it would take to have this demo together.
So we'll be deploying using Ansible and automating it that way, and we can dive into the automation, we can dive into the application, we can do all those things. So there'll be a lot more hands-on workshop-y type stuff. This is kind of finally moving us towards that.
Exactly. So the gist here is we've got this VNF running in containers. I'll talk about that a little bit here in a moment. Those applications are going to be connected to one another, and then I'm going to put a really just simple phone call, like channel originate kind of phone call from one asterisk instance to another, and we'll take a look at the results of that. So in this section, and really kind of for the rest of these sessions, there's a big focus on Kubernetes. And Kubernetes orchestrates your containers. So what are containers? And often when we think of containers, we think of Docker. I mean, they kind of are the ones that brought containerization to the masses. And the gist is, containers are specifically not virtual machines. These are processes and aspects of a process that run in a Linux namespace. So you can have network interfaces that are only visible to a namespace. You can have processes that are only visible to a namespace. So there's this isolation of these processes and components that are isolated from one another. Also with containers, what we have is a way to package all of the requirements for an application in what's called a container image. So we make a specification of what's going to go into an image, and we say it's going to be based on, say, CentOS, and we're going to install some RPMs, and we're going to install our application, and then we're going to run it. And that container can only see those things from the image on disk. So this is one way that they are isolated from one another. And typically in each container, we have a single process that's running. Kubernetes is what allows us to orchestrate these containers. So we'd specify a container that's, say, asterisk. It's got all the prerequisites there. And then we say spark up the asterisk process itself. And Kubernetes is going to schedule this for us. And when I say schedule, I don't mean necessarily like a cron job. I mean that you're going to tell it, hey, I need to have 10 instances of asterisk running. And it's going to look at all of the compute resources that are available to you. And it's going to put that asterisk instance on the appropriate machine. So what we do in Kubernetes is we really have an intent-based way of specifying where our workloads are going to run. It's not so much declarative in that we're going to say, this asterisk instance runs on this specific box. What we're going to say is we're more going to say something like, this asterisk instance needs about this much RAM, it needs this much CPU cycles, and then Kubernetes can go and say, hey, of this pool of nodes that I have available in the cluster, where's the appropriate place to run this asterisk instance?
What satisfies?
Yeah, what satisfies these components and or these intents that you have. And
the inverse of that is even true, where you can say this container should never be scheduled on nodes that have these types of things. So you can do the inverse, where you say, these things must be satisfied, and also do not schedule it on a node that has what we would call a taint.
Right. So kind of your classic like textbook example of don't run these things in the same place is don't run your database on the same machine that you do your backups on. Like that's a no-no. Those should be separated.
And you can do that via metadata to make sure that does, when Kubernetes goes to schedule it, that it actually doesn't do that. It says databases cannot be done on machines that have been marked as backup.
Right, and so you may be able to specify these machines are for, as we described in the last one, for a data plane. They have the right hardware to meet those requirements, and these instances should run on a box like that. So you can set up this labeling, this metadata, so that things wind up in the appropriate place. A tiny bit of background on Kubernetes is that it's headed up by the Cloud Native Computing Foundation, and Kubernetes was donated by Google to this foundation a couple years ago. Google has been using a technology like this for a number of years, and they have their own proprietary version of this called Borg, which is really what runs the guts of Google. So you're kind of getting a lot of this experience that Google has built at a hugely high scale available to you in Kubernetes. And we're going to be using this fairly heavily. So Kubernetes is, it's like Linux in a way that if you're running just pure vanilla Kubernetes, that in a way would be like running just a kernel and building your own Linux from scratch. So one thing that I would say is that you should have kind of a curated Kubernetes experience. If you're going to just use a vanilla Kubernetes that's at the head commit of Kubernetes, it's going to be really difficult for you. And it's just like on your production machines, you're probably not going to use Linux from scratch. You're probably going to use,
CentOS
or Ubuntu or whatever it happens to be. And so one thing to take a look at is Red Hat OpenShift. And I don't just say this as a Red Hatter, I say it because it really is pretty cool. It's a distribution of Kubernetes with a set of other tools for you. Just like if you were to install Linux from scratch and you'd have to pick what tools you would want included in your distribution, it's like you pick CentOS and it's going to have some standard tools that are always useful to you. In the same way, it's like you've got a distribution of Kubernetes, but Red Hat has been like, hey, we're going to set this up in a particular way so that you have some good practices regarding security, and you're going to have the right tools for the job so that you're not fishing around trying to cobble something together.
It has some good biases. I think is a good way to think about it. It's made some decisions for you, so you don't have to worry about understanding all of the implications of how to build these things together. Those biases have been built in for you, so you can effectively download it as a distribution and deploy it. And there's OpenShift Origin, which is the upstream product. Again, just like a CentOS or something where you can just grab it and consume it for free. And then obviously there's the downstream productized, supported, version of it, but they're the same thing.
Absolutely.
So if you want to play with it, look for OpenShift Origin, download it. It's got some good install instructions. It's got the biases. It's got a web interface and all those things.
So while there's a big focus on Kubernetes here, as we continue with our experimentations using VNF Asterisk, it's not the only way that you could deploy this. We also have in the past configured it so we could run it just on bare metal or in a virtual machine or just in Docker containers. And that's also for exploring the other ways that this kind of the field can be laid according to those diagrams that we showed earlier. And for sure, if I'm kind of like in a development mode, I might just have this stuff running in Docker containers, so it's just all on my local machine. I don't necessarily have to worry about Kubernetes scheduling it all over the place. So that may be an earlier phase, is just in Docker, for example. So what are the gaps that we have here technologically? And this is, one of our goals of running Asterisk this way, is to look at the infrastructure that we spin up and create, and then run Asterisk on top of it. And since we're formerly big time Asterisk guys, it's not a big deal, and it makes it easy for us to go and look at what those gaps may be potentially. And there's a number of them. There's, this is still a burgeoning technology, and in a lot of ways, there's a big emphasis in the world of Kubernetes on web applications specifically. So if you're just strictly a web apps guy, there may be 0 to no gaps at all for you. It might be just all set. But in the Asterisk world and in the VNF and NF telecommunications world, we don't have that luxury that everything is just a REST API. So we, there's some stuff here that's a little bit more hardcore, and there's some challenges there. And some of these challenges we've worked around to just make it work. And sometimes in order to document what those happen to be. But some of those gaps, the one that's at the top of my list, is Kubernetes uses something called kubeproxy. And what kubeproxy does is it can act as a load balancer. And so if you've got instances of your web application and you have 2 of them, and you auto scale up to 3 instances, it knows to distribute that. And if you've got stateless web apps, that's no big deal. But if you're in the VoIP world and you've got a bunch of UDP packets and you have this stateful SIP protocol, well, guess what? You're out of luck. That kubeproxy isn't going to be smart enough to do this. So at least in this, in our implementation, we've kind of worked around that, and we've used service discovery in order to figure out where to send that traffic. I don't know that that's what I would recommend in a long term, but it's a way that we've been able to make it work for now. And we look at kind of the future of what we may contribute to in order to satisfy these kind of requirements for something like a kubeproxy. Also, multiple interface support in Kubernetes is something that is like just happening like today, in the last few weeks happening kind of a thing. There are certainly ways to work around it, and there are network plugins for Kubernetes that can give you multiple interfaces per pod. But if you just spin up Kubernetes today and try to do that, you're not going to have it out of the box. You're just going to have 1 interface per pod. So something that I did back in my full-time Asterisk days is I had my networks organized in such a way that I had segmentation for signaling, for media, and for management. So I had that stuff isolated. And I would want to do the same thing with Kubernetes, and I've found ways to emulate this. Something that I'll probably touch on later here is Multis CNI, which is a container network interface that Kubernetes uses. That's a kind of plug-in architecture for Kubernetes, and that particular plugin specifically supports multi-network, and I'll get into that later. Also, in these implementations, we don't touch IPv6 with a 10-foot pole right now. There's some challenges there in Kubernetes land, and we're also looking into that. So that's another area that we we'll probably look at. There are more of these gaps to come, but these are some of my pet gaps.
So yeah, basically the idea here is doing gap analysis and understanding what the future might look like and what's missing so that we can help drive, Kubernetes and different projects to understand, okay, we have these needs, as a non-web application, to try and fill in those gaps and understand what's the most important so that, basically we're driving towards getting a platform that handles more than just web apps 100% of the time. Yeah, absolutely.
No, we'll definitely have it running on Kubernetes, and we can make phone calls over it, and we can get everything working. And I guess this would be a good time to say a kind of a disclaimer about VNF Asterisk is it's meant for exploration and verification of platforms. It's nothing that I would recommend
don't deploy it tonight and start running some traffic on it. Do that, but don't blame me when it falls over.
Yeah, definitely, and don't tell your boss for sure. So the thing is, UDP traffic can go across node to node, but what we would do in Kubernetes typically is we would define what's called a service, which abstracts. So you have say Asterisk and Homer running. And then I would say define a service. And that service is going to say, you call the service, and the service figures out
where to send you.
Where to send it. So I can't define a service for Asterisk and say, load balance this to all of the instances. I have to baby it a little bit more.
Point it right at the IP address and discover where the container is actually running and what its IP address is and all that. Whereas it'd be much nicer just to ask Kubernetes, send me to a container, and it really kind of just figures it out like a proxy.
That will be the ultimate. Also, worth noting at this juncture too is this isn't the only Kubernetes solution for Asterisk. I saw a talk by Sean McCord from last year's AstraCon,
which heavily influenced some of our decisions.
Yeah, absolutely. It was a very nice presentation, and he has a different way of thinking about it too. And I think that he leans on the NATs quite a bit. So that's something to think about and look at, and maybe influence how you might do this for yourself.
NATS is a Go-based message broker, or not broker, messaging platform. So like an ActiveMQ or RabbitMQ or that kind of thing. So not NAT, not the networking NAT, NATS, NATS. So if you want to look it up, it'll tell you more of what it is.
So what specifically is in our recipe? Some of these things you might recognize, some of them you don't. First of all is VNF Asterisk, which is just kind of our tooling around Asterisk is really what it comes down to. So we run Asterisk in a container. It's Asterisk in a container that anybody could run for any purpose. But we've put tooling around it to put it into, to use the paradigm that we explained earlier, where we have a controller that's able to push configurations into Asterisk, for example, and then also some abstraction of a user interface to give you a little bit of visibility. We run it on top of Kubernetes for the orchestration of the VNF. And then also we use Homer for VoIP monitoring and analytics. And as I mentioned earlier, double down on that part. The more dynamic it becomes, the more important your logging and analytics are. We also lean on Ansible a ton. So Ansible is configuration management, and it's agentless. So that means that it's not like there's an agent that runs on each machine that you're going to manage that phones back home and you have to figure out how to install that agent. it just uses an SSH connection, and then it requires a Python interpreter to be available on the machine that you're going to manage. So for most operating systems, that means that other than booting the OS, you don't really need to do much else to start managing it.
So really, like the workflow would be Pixie boot your hardware, get in a piece of operating system onto it that satisfies these two basic requirements, which is SSH and a Python interpreter, and then you can basically run Ansible against it and automate the rest of the deployment of that operating system.
So this is what really saved our bacon last night, as we noticed that there were some issues in our lab. And we're just like, hey, you know what? We're just gonna.
Doug tore down and deleted his entire virtual machine, is your virt host, and basically rebuilt the entire virt host in order to allow us to rebuild the demo on top of it. And that was like 10 minutes or something.
It really didn't take a whole lot of time. I was a little bit more nervous about it than usual because I knew I'd give a demo the next day, but it worked, and it was definitely, like kind of a high five moment when it saved us. And some other things that we really like about Ansible is you define what are called playbooks, which is like a series of steps that you're going to run. In YAML, which is just like really easy to read.
Human readable.
And even more so than that, what we love about Ansible is that the documentation is so good that we hardly memorize anything for it. I just refer to that documentation all the time, and it's great. It makes it so that I don't have to know some arcane stuff about it. I have a link in my bookmarks bar. It's the third one over. It says all modules Ansible, and I just click on that every time I need to write anything and just figure out what the syntax is. It's very straightforward. So it's really good. One of the best things about it. It can, yes. So the question is basically, can it fill up the databases and Yeah. So Ansible, if it can't do it through a native module, you can have it run a shell script or anything. So it can just execute basically another piece of software if it needs to on the remote host. So if you are using, what's that called? What's the database management tool? Asterisk uses it for the table creation and lifecycle management of the Alembic. So it could run that to basically lifecycle management your database, and then you could have it run, let's say you're running MySQL or something, you could have Ansible run a shell command that just pulled in the data and populated it. But you wouldn't necessarily write it in, like there isn't a module for like database population in Ansible, but it can just run a shell command or just a regular command. It doesn't necessarily need a shell. It can use a more slimmed down shell, but yeah. Excellent. So I'm going to zip through a little bit here because I realize that we're going to get close to... We have 14 minutes. Yeah, we have 14 minutes. So I'm going to go over this diagram real quick because it's about to get into terminal and browser mode, and there's going to be a few things happening. But the gist here is we really have Asterisk and Homer running, and we have something to control the configuration in Asterisk. So we have packaged together in pods, which are logically grouped containers, Asterisk and a capture agent, and those we can scale. So we'll create a couple deployments of those. And then Homer, while it can be scaled, in this particular case is mostly static. So we've got the pieces that we need for, is mostly static in terms of scale, is we just have one instance of it going, and it's got the parts that really make Homer. So it's got the SIP proxy that's able to pull apart those SIP messages and then display them for you in a pretty way, which it does by putting them into MySQL and displaying them through a web app, which uses an API into Homer to pull out that data. But on the VNF Asterisk side, we also have a user interface to show you kind of what's been discovered about Asterisk, what are the configurations that we pushed into it. It's pretty bare bones, but we wanted to do this to kind of show that there's these layers of abstraction. All right, so let's move on to having a demo of VNF Asterisk.
If you're downloading anything like really heavy right now, please stop.
It's fine. All right.
I mean it.
So let's see here. Get the pieces that I need. All right. So the first thing that we're going to do here is we're going to come into Kubernetes and we're going to list the pods that we have running here. And you're going to see that we have Asterisk and we have 2 instances of Asterisk. We didn't choose which nodes for these to run on. Kubernetes did that for us. So I put in this output the node that they run on, and they run on our 2nd and 3rd nodes here.
So the column on the far right is representing the 3 physical machines, or the 3 virtual machines in this case, that are part of our Kubernetes cluster.
And we also have a controller, which is, as part of that block diagram that we showed earlier, this is part of our control plane. This is what we put the instructions into in order to configure Asterisk. And we'll probably touch on this more later, but we use a feature of Asterisk called sorcery, which allows us to push configurations into Asterisk. We also have this cron process, which is actually part of Homer as it rotates out the data on a daily basis. And then we have 3 instances of etcd. etcd is a tool that you can use for service discovery, and it's, in short, it's a distributed key value pair database. It's pretty easy to use and it's pretty flexible, and we use that in order to discover Asterisk as it comes up. So
this is the thing that I guess we would prefer to be using the service inside of Kubernetes instead of etcd.
I think
Maybe
six and a half dozen.
You kind of need both.
6 1/2 dozen. So it's yeah. I guess that one's.
I guess
up
we
for,
still need it for the controller to know where things are.
Yeah. So up for debate. Kubernetes also has its own instance of etcd that it runs, and that's what Leif is mentioning is, should we use that one or should we use our own instance? In this case, I chose to run my own instance of it.
Separation of the application from the infrastructure. So.
Right. So it may be redundant in some ways, so that's why we still debate it. There's an instance of Comma-Ilio. In this case, it's not being used as our like front-end proxy for the traffic or whatever. This is the one that's used for Homer. So inside each of these Asterisk pods, there's Asterisk and an instance of the capture agent, and it's sending data to this Comma-Ilio. So that particular Comma-Ilio is, as part of Homer, is inserting data into this instance of MySQL, which is displayed through this web app. And we also have this last one, the VNF user interface, which shows what's been discovered about Asterisk. So let's take a look at this VNF Asterisk user interface. So this is what we have to give you some visibility into the discovered instances here. And in the discovered instances, we have 2 instances of Asterisk, as we saw at the terminal looking at Kubernetes. And we've given them cute names inspired by the way Docker names containers. And these
names are dynamically provisioned. We didn't pick them.
Right. Yeah. So they're generated dynamically, and it tells us the IP address at which it's located, and it assigns a unique ID to these. Later in the day, we'll use these unique IDs to dynamically create trunks between these instances. Anyways, as much as there's like a lot going on here with Kubernetes and all these instances of everything running, at the end of the day, you can go ahead and get yourself into a command line. So what I'm going to do is come up to an asterisk command line, and it's got a random name, right? You know, this is, we just had our intent to spin up asterisk, and it named it for us. And I'm going to do, I'm going to show the trunks that have been created. So our controller created these trunks, and we have one to stupefied yellow, which is one of those goofy, cute names that we did. And I'm going to go ahead and originate a call to this machine, and we'll just have it wait. So at the end of the day, yes, there's a lot of abstraction, but I can still just do asterisk RVVV, get in there, and use it just like asterisk. There's no magic in the end. So that being said, we still are collecting analytics on these. So this is, it's a long bash command, but at the end of the day, I'm just going to output the results of CSV CDR. And we can see there's a call I made earlier, and then one I just made a moment ago, and it said that it answered the call. It was, you know, executed this wait 5, etc. So lastly, but not least, that information should also be collected in Homer. So if I come back to Homer and I search my calls for today, I should have this call at 12:09 here, and we can see this ladder diagram from Homer showing us that here's the invite, it's trying, answered with an OK, it acted, and then we say goodbye at the end of the call. There's no RTP in this particular call because it was just wait with no media, but if there was media there, Homer can also give you some statistics on that using RTCP, etc. So later today, we'll actually show us spinning up all of this stuff and how it, you know, dynamically creates these instances, how the controller assigns the assigns these configurations, creates trunks, and then we can put a call over it and then see where and how that call was created. So that's the short demo for now, and we've got just a couple minutes left.
4 minutes before lunch, if there's any questions or thoughts.
Are you going to make all these sort of setups available so you can play around with them?
Yep.
Yeah, absolutely.
Everything's on GitHub right now, and so yeah, all the commands we're going to run are being pulled from our public repositories, and you'll be able to do all the same stuff. You should be able to automate everything. I have a single vert host that spins all this up, and will build up all the infrastructure, build a 4 virtual machine, 1 kube master, and 3 kube nodes, and then Doug will basically play his stuff on top of that and build up basically everything you see here. So we're kind of showing you that whole, here's the end, and then we'll show you how to get there.
Thank you. Thank you very much.
Doug did a lot of work.
It was, thanks. It was just so much fun,
yeah.
and a great excuse to spin up asterisk. And I mean, we love it, of course.
Yeah. So, anything else before lunch? Cool. Thanks.
All right. Thanks, everyone.